Excellent. Good. Well, thanks for coming out again today. Just a quick reminder of what else is up this week. There's a couple of webinars tomorrow, not by us, one by Zeiss on image analysis in Zen, and one by the Center for Dynamic Scale Science on biological sample prep for EM. So feel free to check those out. I sent out links in last night's email. And then we'll be back here on Thursday, and I'm going to do a presentation on live cell imaging. So with the hopes that someday we'll be able to return to the facility and actually look at living samples again. But what I want to do today is to kind of take a step back. So the last couple of weeks in these sessions, we've been talking about segmentation. And we started with really basic segmentation, basically just manual thresholding or some sort of automated thresholding, like using an OTSU. And then Aaron and Chris took us down into some more interesting and advanced segmentation techniques using various machine learning algorithms. And today we're going to kind of step back to, I guess, probably, I guess it's not the most simple, maybe the second most simple way to do segmentation manually. So I think this has some relevance because it popped up a couple times. One of the questions that was asked about machine learning was, how do you know how accurate it is? So one of the ways to do it is to take your data sample and manually segment a small portion of it and use that as your ground truth and test it against your machine learning algorithm to see how good it is. So that's one reason why you might want to do the manual type segmentation I'm going to show you today. And the other reason is just if you've got something that's just far too difficult, there might be the only way to do it is manually. And I mean, I think we've seen this a lot in the serial sectioning EM world. There are some really good machine learning algorithms there now. They're getting better all the time, but still a lot of these labs often employ an army of undergrads to do some manual tracing and segmenting. So the funny thing was, I think the question came up in one of our previous webinars was, what program would you use to do that? And we were kind of stumped at the moment because we couldn't think of any really good ones to do it in. So I'm going to show you how to do it in arivis today, which is obviously a commercially available package that we have at the facility that you can use. And Erin actually just came across an open source program earlier today as well. So maybe she can post a link to that in the chat. But I'm going to show you how to do this in arivis. So let's just start out with something very, very simple. So I'm going to open up a file that I have here. So with arivis, all of the files that you use are these SIS files. So whatever image you have, if you have a CZI or just a bunch of TIFFs, you basically just drag and drop it onto this desktop here, and then it's going to automatically convert that to an SIS. So I've already converted these two, so I'm going to start with this one. And this is just a really simple 3D image of a nucleus. Okay, there's nothing else here. It's just one channel. We can go top to bottom through that nucleus, and that's what it is. Okay, so maybe I'll just start with, because maybe not all of you are familiar with arivis. I'll show you how you would just do this normally if you're just doing, say, a manual thresholding, and then the next thing I'll do is show you how you would actually do it if you're drawing and annotating it yourself. So this is usually referred to as annotation, which, because I come from a pathology background, it always seems bizarre to me. I think annotation is like writing stuff on the screen next to interesting objects, but this idea of manual segmentation is also referred to as annotation. So if we just want to do a manual threshold like I showed you how to do in ImageJ a while ago, what we do is we go to this analysis tab and then pop out this analysis panel. And down here on the bottom left, what you have are a whole bunch of different functions that you can apply to your image, and they're grouped into these little categories. And basically what you have to do is you have to select these in the order that they're grouped. So you'd start with the red ones, then go to the green ones, and then the purple ones, and so on and so forth. So the red ones here are mostly just different types of filters. So this is what you do on your data if you had some noisy data and you needed to clean it up ahead of time. So what we've been showing in the last couple of weeks, those median filters, Gaussian blurs, things like that. I'm not going to do any of those on this data. It's pretty clean. You can see there's a nice black background here, so we're not going to worry about that. But what we go down to here is just grab this intensity threshold option. And I'm just going to drag that up here. And you can see basically this just shows us of our 8-bit image what pixel intensities we're going to grab. So we have an 8-bit image, so it goes from 0 to 255 intensity values. And right now this threshold is set to collect from 104 to 255. Okay. What you can do is if you hit the little eyeball, it's going to give you a preview of what that looks like. And then this little eyedropper tool here, you can use this if it looks like it didn't get everything. So you can see we didn't get far enough on the outside here. So we can just keep eyedroppering tooling closer to the outside until it looks like we just about have everything. Okay. You can also just type numbers in here on your own. So we could put 70. This is just previewing on this plane. If I go to a different plane, you can see, you might be able to see here, it might be too small on your monitor, but there's a cyan pixel here, which means it's finding another object, not just this one big one that we want in the middle. So what we can do is, obviously we don't want all of these like 1 or 2 pixel objects in the end. So what we can do is go down here to these segment operations, and I'm just going to grab the segment filter. And so this will be applied after it does that threshold. And I'm just going to tell it let the object has to have, let's say, at least 1,000 voxels in it. And then the final operation here is just storing the output of this. And all I want to do is just store the objects that come out of the segment filter. I don't care about what comes out of this intensity threshold. All right. Right now it's set up to do this on the current view, which would mean it would just do it on this one single Z slice. So I'm going to switch this to current image sets. And I'll hit play. And we get a little progress bar down in the bottom there. And then in the end, we get this object menu. So it's only found one object. I can click on that. I can tell it to actually show the one object what it's found. And if we scroll up and down, we see we have that object that has this weird hole in the side of it. All right. This has all been done in the 2D viewer, what arivis calls a 2D viewer, so you're just seeing a single slice. Once we have this object cut out, we can go to the 4D viewer, which is this cube at the bottom here. And if I click on that, I can now see the 3D rendering of that nucleus. Okay, so we can see that weird hole that was in the top of it where there wasn't any signal there. And if we look at it from the edge here, we can see it's kind of cut out on the inside there. And if I'd actually shown you, this was originally a 2-channel image. I think it had lysosomes, or I think it was lysosomes with the other label. You can see this was actually near the edge of the cell, and then the cytoplasm came out this way on the left here. And a bunch of those organelles were packed up against the nucleus here. So that's what's actually carved out in the inside there. So that's just the really simple manual thresholding that I showed you before in ImageJ. So if for some reason that sort of thresholding wasn't working for you, and I'm going to show you an example later where it doesn't. Let's just get rid of this object. We can do this manually. So I'm just going to go back to the image here. And what I'm going to do is just go to one side of the Z stack. And now up along the top here, these are annotation tools or manual segmenting tools along here. And what I'm going to do is grab this one. This says the Draw Objects tool. This says create an object by drawing slices at different planes. So I'm just going to click on that, and that gives us some more options along the bottom here. And the important ones really are just this brush and the eraser. Okay, so I'm going to grab this brush, and I can adjust the size of it. You can see there it is there. And adjust the size of it here. And all I'm going to do is just go around the outside of our object. Now what I'm going to do is I'm going to go to, let's say, the middle of our object. You can see there's still a dotted line of that original one that I drew on the bottom. What I'm going to do is I'm going to draw another one on this Z slice. I'm not doing this absolutely perfectly, but whoops. Good chance to show you the eraser tool. Go back to our brush here. That. Okay. And now if I go back down, what it's done here is now it shows us this blue shaded region with the dotted line around it. That means it's interpolating these slices based on the first one we drew and this last one that we drew. I don't know why these things are appearing. Apparently I didn't quite erase everything. This is going to be really annoying. So now what you do is you just go through these Z-planes and try and gradually fix this up. If I had have done this right, that first one up at the top there wouldn't be there. And the more of these that you do, the better it's going to learn and the more accurate it's going to be in the end. But often you don't have to do too many. Part where this gets a little tricky is when you have an object like this that's fat in the middle, because obviously it just tries to interpolate that large volume continuing all the way. So when you get to the other side, it's kind of annoying. You have to totally erase everything. Just on the very top one, and then go back and there's our object, maybe there. And now it's going to reinterpolate it. Okay. So I've done a bad job of this, but I think you get the idea. And let's say that was okay. So I just click the check mark here, and it's going to create that object. And then again, if we go to our 3D viewer, there we go. There's our nucleus. Once again, segmented out manually. It's this weirdness at the side here that I accidentally made. Okay, so that was pretty easy. There's just a single nucleus. There's lots of contrast. There's no problem. Let's take a look at something that's a little more complicated. Back to our 2D viewer. So I'm going to open up this image. So this is, again, nuclei. It's just a whole bunch of nuclei. This is actually data off a light sheet microscope imaging through an intact retina of a mouse. So as we go up and down, you can see there's this is the inner layer and outer layer of cells in the retina. And you can see we've got a whole bunch of different nuclei there that we want to try and segment out. So if we go back to our analysis panel and try to run some of that stuff that we were doing before. So for example, let's try and do, this is manual intensity. And we'll keep this segment filter again. So this time I'm going to use volumes. I'm going to make this smaller. It needs to be about 10. Okay, so if we just try to preview what this looks like, that didn't get many. Okay, that's doing a pretty good job. Well, I think if you zoom in, you can see it's still missing quite a few. So what happens here is if we manually adjust our threshold low enough to get these dim ones, then our brighter ones all bleed into one another. So this isn't going to work very well. So let's get rid of that. And instead, let's try an automatic threshold. So this is like that. This is an OTSU thresholding method like I showed you before. So let's see what this does if we try this. So that looks pretty good here, but let's run it for the whole volume. I'm just going to let this run. Our volume cutoff's too high. Let's go back. Okay. Now we can see that we missed a whole bunch of structures. And if we take a look at the 3D render here, yeah, you can see we've missed all kinds of them. Okay. So there's another option in arivis here that's really good for nuclei. So instead of using this automatic threshold, what I'm going to do is I'm going to grab this Blob Finder. So what the Blob Finder does is it actually looks for circular objects. So what we can do is take our ruler tool here up at the top and measure the size of an average object. Looks like it's about 2.5 microns. So we're going to tell it to look for 2.5 micron sized blobs. Oops, sorry. I need to put that up here. 2.5 micron sized blobs. And again, we'll leave this as it has to have a volume of 2 microns, 5 microns cubed. All right, and if we run this time, back to here, let's just preview this. Okay, so right now we have our threshold is a little too high here. Let's turn this back down so that we get those dimmer objects. And then there's something else here that's the split sensitivity. So that is kind of like a watershed function. So it just tries to decide if one object where there's continuous intensity across it, if it actually sees two peaks within that object, when it's going to split those. So it looks like here we have a bunch of these single objects, things that probably should have been a single object that have been split. I'm just going to reduce that a little bit as well. Okay. So these are two things that you could sit here adjusting all day, the threshold and the split sensitivity. But unfortunately, what's going to happen is you're never going to get it right. I'm just running it on the full data set now. And to be honest, this is a really bad data set, because if I was to look at this by eye, I think I'd have been, I mean, I've been looking at it for the last 3 days, and I can't even tell where some of these things should be split into multiple objects. So the only thing that's easy to tell is these nuclei that are kind of sitting on their own in between the two layers. So these ones you can tell, it looks like it's done a pretty good job here. It hasn't segmented them into multiple nuclei. They're all staying as single objects, which is good. But if we were to start looking in the inside here, I'm sure we'd be able to find a whole bunch of errors. This one right here is should probably be 2, one there and one over here, maybe even 3, one up here and one down here. So with a data set that's less than optimal, like this one, or if you just wanted to check and see how accurate this actually is, you can go back and do a manual processing of it. So we get rid of all of these objects that we just found automatically. And what I'm going to do is just zoom in. I think if I go up to this guy, yeah, there's 2. So I'm just going to try and manually segment out those 2 nuclei. Okay. So just like before, what we're going to do is just start at the bottom, open up this tool. Going to make it a little smaller this time. And because these objects are small enough that they only lost a couple planes, I'm just going to go through each plane. And that looks like about where it ends, so we'll just get rid of it there. All right, so we hit the checkbox, that one's done. And then we're going to do that other one. So same thing, just go to one side, go back to the brush tool. You don't have to do every frame. That looks like it's pretty much gone there. Okay, then we hit the checkbox again. And now we should have both of those objects. So if we go over to the 4D viewer again, zoom back out, there are those 2 nuclei that we just manually segmented out. And that's the rest of our volume there. Yeah, so you can just toggle these on and off to see how good of a job you actually did. Okay, and then you hire 10 undergrads to sit down and do this all day and all the rest of them. Does that make sense? So the one other question that people probably have is, can you start with the automatic segmentation and then fix it up later? And the answer to that is yes. So let's go back. Open up our analysis panel again and just let this run. Okay. So we have all of our data here, all segmented out automatically. And now we want to go through and just quality control this. So I'm going to close the pipeline here, go back to the 2D viewer, and let's see if there's anything obvious here. Let's take a look. Let's say we thought these two objects here should actually be the same thing. Probably not, but let's pretend we thought those two should be. So what I can do is, again, click on my Draw Objects tool here. And if I grab the selection tool, I can just select both of those. Just hold down the Shift button when I click on, should be Shift, maybe not Shift. Too many segments there. Sorry, run selection tool. It's this arrow up at the top here. All right, so I've selected both of those, and they should be highlighted now in our objects list here. You can only see one because there's so many objects here. But if I right-click over here, there's this option to merge these objects. So I merge them. It says, do you want to remove the original ones? Yes. Now I just have one object there. All right. Now let's say we had another one like this one, but we thought this was actually 2 nuclei. So this is a little more labor intensive, but basically what you do is go back to your drawing panel, grab that eraser tool, just make it nice and small. And then what you have to do, now here you need this selection tool, and then grab the eraser. And you just have to go through and cut it in half on every plane, okay? And if you do that all the way through it, and then in the end, you hit the checkbox, and then it'll split it into 2 objects. It's still connected at the bottom, that's why they're staying the same color. But if you've done that all the way through, it would split it into 2. So that's how you can go back and manually quality control all of your data. So definitely not an easy process, but there are just some data sets out there that this is the only way to do it. Also, if you just have something small, it's just a few nuclei or something on the screen that you want to make sure you do a really good job of, this is a good way to do it that way as well. Okay. Anybody have any questions about that?